The next one, what is hydrostatic equilibrium? And this picture is your hint. So hydrostatic equilibrium is when the inward force of gravity is balanced by the outward force from nuclear explosions or nuclear fusion in the core. All right. So what happens to the core of a red giant star? So what happens is that the core is not fusing, so there's just ash, and because of that, there's nothing to counteract gravity, so it shrinks. Eventually, though, as the core shrinks, it gets hot and it starts to heat up, and eventually it'll shrink to a point where the temperature rises enough that it can fuse helium into carbon. Okay, so related question, what happens to the outer layers of the red giant? So the hydrogen shell, the fusion in the layers above the core and the shell above the core, what they do is that they blow the star outwards so that the outer parts of the star expand. Okay, next question. Where does hydrogen fusion occur inside low mass red giant stars? So, as just mentioned, hydrogen fusion occurs in a shell above the core. So you can see the shells here. Okay, so what food does the internal structure of the supergiant star look like? So, looks like an onion with different layers of shell fusion surrounding the core. All right, next one. How does the brightness and temperature of a red giant star change, or a star? How does the temperature and brightness of a star change as it becomes a red giant? So, looking at the picture, what happens is that the star expands, so it becomes a giant, so it becomes brighter, and as it does, it becomes redder, so it cools down. So red giant stars are bright, but they're also cool. All right, next question. What is the heaviest element created in any star during fusion? So looking at the picture, you can see it. Iron is the last material that can be created through fusion in any star. All right. So related question. So why can't a star with iron in its core support itself against gravity? So the reason why is that the fusion of iron does not release any extra heat that can oppose the shrinking. Well, that can oppose gravity. Okay, next one. Consider hydrogen and helium, which requires a higher fusion temperature and why. So you have hydrogen nuclei here fusing, and here you have helium nuclei fusing. So which one of these would you expect requires a higher fusion temperature and why? So helium requires a higher fusion temperature because it's heavier, meaning that it has more protons, and more protons means more positive force repulsion, so it needs to be held at a higher temperature in order to squeeze them together to make them fuse.